In this video, we are going to be continuing 4.1 and the last part of 4.1 and then we'll start off with 4.2. So in the previous video, we were doing actually the last problem, problem number 12, which is negative 9 m to the power 5t times 3 m to the power negative 2t cubed divided by 4t to the power 6, all to the exponent negative 3. Whenever you have a quotient and you have an exponent negative, you can actually take the reciprocal and make the exponent positive. So that's what we did in this step. Negative 9 m to the power 5t times, I flipped the numerator and the denominator, so it's 4t to the power 6 divided by 3 m to the power negative 2t cube, all to the power positive 3. Then we use the rule of exponent here, and then negative 9 p to the m to the power 5t, and then we have to raise each member here to the exponent 3. So it's 4 cube, t to the power 6 cube, 3 cube, m to the power negative 2 cube, t cube to the cube. Then we'll give values for this. 4 cube is 64. Then when you have an exponent power over a power, you're going to multiply that. So that is t to the power 18. Then 3 cube, which is a 27, m to the power negative 6, negative 2 times 3. I'm multiplying these two. Then we are multiplying the exponent t times 3, which is a 9, t to the power 9. So we have these, and we are going to simplify this expression, t to the power 9. So I can strike this one and make this one minus 9 over here by using the quotient rule. And then we have m to the power negative 6. I'm going to make it positive 6 on the numerator. Then we can clean up right now, which is equal to negative 9 m to the power 11 t times 64 t to the power 18 minus 9, which is a 9, divided by 27. So it is negative 9. Then you can combine the t exponents, t to the power 1, t to the power 9, that will become t to the power 10. Then we can leave m to the power 11 as is. Then 64 on the numerator divided by 27. It will be 9 going in 27 3 times. So we have negative 64 over 3, t to the power 10, m to the power 11. Hope this video helps. Let's try some of the problems which are slightly different. More examples with exponents. 2 over 3 to the power negative 2, because whenever you have a negative exponent, you're going to flip the numerator and the denominator and make the exponent positive. Then negative 1/2 square, which is 1 square over 2 square, which is equal to 4. And then you know that anything to the power 0 is 1. So if you simplify that, 3 square over 2 square, negative 1 over 4 plus 1. 1 square is just 1. So it will be 9 over 4 minus 1 over 4 plus 1, which is 8 over 4 plus 1, so which is 2 plus 1, which is 3. The next one, 1 over 6 to the power negative 1. So flip and then make the exponent positive, which is 6 to the power 1. Anything to the power 0 is 1. Then again you flip and make the exponent positive. So it is 6 to the power 1 plus 1 minus 4 square over 1 square, so which is 16. That is 7 minus 16, which is a negative 9. So that completes 4.1. Now let's start with 4.2. Section 4.2, it's addition and subtraction of polynomials and polynomial functions. A polynomial in X is defined as a finite number of terms of the form a times x to the exponent n, where a is a real number and the exponent n is a whole number. For each term, a is called the coefficient, in other words, it's a number in front of the variable, and n is called the degree of the term. Consider the polynomial 3x to the power 5 plus 1 half x plus 7. A monomial is a polynomial with only one term. Binomial, a polynomial with two terms. Trinomial, a polynomial with three terms. In descending order, the highest degree term is written first and is called the leading term. Its coefficient is called the leading coefficient. The number in front of the number in front of the highest degree term is the leading term. The degree of a polynomial is the greatest degree of all its terms. Thus, the leading term determines the degree of the polynomial. Now, we are going to see some examples. Add the polynomials, add the coefficients of like terms. So, 2x squared plus 5x minus 2 is the first polynomial. It is added to 6x squared minus 8x minus 8. So, now add the like terms, so which is 2x squared plus 6x squared. We are going to add the x squared terms. Then you add the x terms, 5x minus 8x. Then you're going to add the numbers, which is negative 2, negative 8. Negative times positive is negative. So it is 2x squared plus 6x squared, which is 8x squared. 5x minus 8x, that is a negative 3x. Then minus negative 2 minus 8, which is a negative 10. So it's 8x squared minus 3x minus 10. So we're adding the like terms. The like terms, x squared terms are the like terms. X squared terms are the like terms. X terms are the like terms. And then the numbers. Let's try one with fractions. Negative 1/4 m squared minus 2m plus 1/3 plus 3/4 m squared plus 7m minus 1/12. We are going to combine the like terms here. So you have m squared. So we'll combine the terms, coefficients, negative 1/4, which is a coefficient of m squared. And we are going to add that with the coefficient of m squared in the second. So those are m squared terms. Then we are going to take the m terms, which has negative 2 in the first one, positive 7 in the second one. So negative 2, positive 7, m. Then we are going to add the numbers, which is 1/3 minus 1/12. So here, if you combine the numerator, as long as the denominator is the same, we can add the numerator, which is negative 1 plus 3, which is positive 2 over 4m squared plus 5m. Then you are going to adjust the denominator here. That is times 4 times 4. So it is 4 minus 1. So it is 3 over 12. If we simplify that further, this can be reduced. It is 1/2 m squared plus 5m. Reduce this, which is 1/4. This will be 4 minus 1, so 3 over 12, that will be positive 1/4. Let's now subtract. So when you subtract, you keep the first polynomial as is. Then distribute the minus sign. So negative 4x square, the negative negative, that will be positive 7x, then you have a minus 2. Now you combine the like terms, 3 minus 4, so 3 minus 4 x square, then you have 2 plus 7 x, 2 plus 7x, then combine the numbers, just negative 5 minus 2. So negative 5 minus 2. So that will be negative 1x square plus 9x minus 7. So negative x square plus 9x minus 7. Subtract 1/2 p cube plus 1/3 p square plus 1/2 p from 1/3 p cube plus 3/4 p square minus p. So if you look at the statement, subtract 4 from 7. You write 7 first and then subtract 4 and write as 3. So anything that comes after the word from goes first. So here after the word from, we get this polynomial. So this goes first. So 1/3 p cube plus 3/4 p square minus p, then minus the first one, 1/2 p cube plus 1/3 p square plus 1/2 p. So let's write the first one as is. Then you distribute the second one. So negative 1/2 p cube, negative 1/3 p square, negative 1/2 p. We are going to combine the like terms. So p cube with the p cube. So combine the coefficients. It's 1/3 and then minus 1/2 p cube. Then we are going to combine the p square, that we have p square and a p square. So take the coefficients for that. So 3/4 of p square and minus 1/3. Don't forget to write the p square. And then we have to collect the p's, which are minus p minus half p. So minus p, so which is minus 1 minus 1/2 p. So minus 1 minus 1/2 of p. So each one is a fraction. We have to adjust the denominator. So it is times 2 times 3. So we get 2 minus 3, which is negative 1 over 6 p cube. Then here you're going to adjust the denominator, multiplying by 3, multiplying this by 4. So 9 minus 4, which is 5 over 12 p square. Then this is going to be, we're going to divide this by 1 and multiply by 2 here. So it is minus 2 minus 1. That will be minus 3 over 2 p. We'll continue the second half of 4.2 in the next video. Hope this video helped.